Okay, welcome everyone. This is Calculus 1, Math 241, and this is the first lecture. So at the beginning, for the first couple lectures, we'll just do a review of, algebra, pre-calculus. So this particular section is graphs, models and functions. And I'm relatively new to, doing lectures on an iPad, so bear with me. Yeah, and you can always speed it up, right? Anyway, yeah, so let's start with actually, I want this one. Let's start with graphing, right? Making a couple graphs. And I'll go rather fast, right? Because that's something you guys should know already. So this is graphing. And yeah, let's start with the example 1. And yeah, graph something simple like just a parabola, so minus negative x squared plus 2. Right, so we're just graphing it by plotting points. So we'll start with the table. Pick a couple. See, I'm practicing making the lines straight. Sometimes I am succeeding, as you can see, sometimes I don't. Well, anyway. So we have negative x squared, right? That's how we get the y values, plus 2. And then we pick couple x's, right? So we have a parabola that's symmetrical with respect to y-axis. So it's good to see a couple points on the left and couple points on the right of the x-axis, y-axis. 0, 1, and 2. All right, so we plug in, so there is a minus, right, in front of it. This is a minus. Let me erase that. Okay, so we have negative x squared plus 2. So we take that negative 2 and we plug it in. Maybe I'll do the first one. All right, so I take y equals, there's that negative that sits in front of the x. Then I'm plugging in that negative 2, squaring it, and then adding 2 at the end. Okay, so we have negative 2 times negative 2 is 4, negative 4 plus 2, negative 2. Right, so that's our first point, negative 2, negative 2. And then we do the same thing with the rest of those x's. So the first one was negative 2. The second one is going to be, I have 1 in my notes. Then the next one will be 2. And then these are symmetrical, right? So it has to be the same. So 2 and negative 2. All right, so we have couple points, 5 exactly, and yeah, let's plot them. So I'm trying to make those lines straight, but I know I need to stop and then move it down. Okay, well, whatever. All right, so we have, how should we do it? Maybe like this. So 1, 2, 1, 2. Yes, we don't need more than that, right? So for negative 2, I get negative 2. So negative 2, negative 2. Let me change color. Actually, let's make it maybe reddish. So negative 2 is negative 2. For positive 2, we get negative 2 as well. So that would be here. Then I have for negative 1, I have 1. For positive 1, I also have 1. And for 0, I get 2. Yeah, so we have a parabola, right? So connect those points. And I think I can also make it stop. Okay. Yeah, this time I succeeded. Yeah, so we have that parabola, right? Let me label it. So y equals, so this is negative x squared plus 2. Yeah, so now for I'll give you a couple problems to practice to do this on your own. So practice. So whenever you have the practice problem, I would like you to actually solve them by yourself, right? And then show work, whatever you need to show. So the first one, and then usually I give you answers, but this time I don't think I will. This one is negative square root of x. And the second one is 2 minus x. So it's just a straight line. All right. Yeah, so do something, right, similar to what I did, right? So pick a couple x's and then, yeah, plot the points and graph it. All right, so that was graphing, right? We're not going to do anything more sophisticated here at this point. And let's move on. So the second thing we'll talk about is intercepts, x and y intercepts. So x comma y intercepts. All right, so yeah, well, let's start with an example. Example 2. And we'll find intercepts given, an equation or a function. So find x and y intercepts. This is s at the end here. And the function we have is f of x equals x cubed minus 4x. All right, so let's start with x-intercepts. Okay, so x-intercepts. Let me rewrite that. Or let's just do this. Okay, so x-intercepts. Yeah, so for x-intercept, right? X-intercept is a point sitting on the x-axis, so y value for that will be equal to 0. So let me write that, y equals 0. So we take that function, whatever we have, and make it equal to 0. So x cubed minus 4x equals 0. And then we solve it, right? So there's a couple of ways we could solve it. I think the easiest way would be maybe to factor x out. So x out, what I have left is x squared minus 4 equals 0. And now I can factor that expression inside parentheses. Right? So we have x plus 2, x minus 2. Right, then we could use that, I think it's called zero product property, right? So either this is equal to 0, this is equal to 0, or this. Right, so I have x equals 0. I don't need to solve it or anything. I already have that 0, right, or that x-intercept. Then the second one, yeah, we can solve it quickly, so equals 0. So x would be negative 2. And then the last one, right, so we have x minus 2 equals to 0. And so again, we solve it and we get x equals 2. All right, so we have we found 3 x-intercepts. So x, let's list them, right? So the first one would be 0, 0. The second one will be negative 2, 0. Right, so so what we found is axis, right? Axis of those points, right? So the y value is always 0, right? So I'm just writing them out to 0. All right, so we found x-intercepts. Let's find y-intercept. So right, so this is x-intercept, and now let's do y-intercepts. Right, so for y-intercept, x is equal to 0. Okay, so there is only one y-intercept, right? If we had more than one y-intercept, that wouldn't be a function. So that's relatively easy, right? So if we have x equals to 0, right, we just substitute 0 for x in our function and we get y-intercept. So let's do that, right? So we have y equals x cubed minus 4x. And we substitute 0 for x, so we get y equals 0 to the third minus 4 times 0. Okay, so we get 0. Right, so that y-intercept is simply zero, 0. Okay, yeah, so that's it for intercepts. We could also graph that function, right? That'd be kind of interesting to see where those intercepts are, and just kind of see them, right? So let's make a graph. Oh, this time I succeeded. Okay, so we have 3 x-intercepts and 1 y-intercept, which is the same as the, make it purple maybe. All right, so we have -2 is one of them, then +2, and then another one is a 0. Right, so the function is x cubed. Let me write it here. So y equals, I think it's x cubed, what was it? Minus 4x. All right, so if we look at end behavior, right, if we look at general shape of this function, it's going to be something like this. Right, so we know that I'm going to start here and end there, right, and then I'll make those turning points. Okay, so we have, this one was -2, 0. This is 0, 0. And then the last one was 2, 0. Right, so 3 x-intercept, among them there is the 0, 0, which is also the y-intercept. Okay, so next thing I'd like to review is, let's see, is symmetry. Right, so we have, in general, we have 3 types of symmetry, right? Something can be symmetrical with respect to y-axis, x-axis, and then origin. In general, right, in algebra, we look at just the first, the symmetry with respect to y-axis and then symmetry with respect to origin, because, well, anyway, let me start with that, with the first one. So symmetry with respect to, so WRT. Let's start with the one with respect to y-axis. Okay, functions like that are usually referred to as even, right? So function that's symmetrical with respect to y-axis will be called even function. And let me give you some little bit of little graph. Okay, so yeah, something like this. So let's look at Let's have those two couple of points, some kind of reference. Alright, so I tried to make it symmetrical with respect to y-axis. I hope I succeeded more or less, right? Maybe those ends here are not perfect. Let me try again. Of course, I didn't mean to erase the whole thing, but I did. Okay, I don't know if this one is better. Maybe not. Anyway, yeah, so coordinates of those 2 points, right, will be, this one will be x. If this one is x and y, well, this one will be negative x and y. Okay, and then the condition, right? If I take f of negative x, and if I plug in negative x into the function, then I'll get the same value as if I was plugging in f of x. And so you guys see that for negative x and x, y's are the same, right? So you can treat those two as y's. All right, so that was the first one, symmetry with respect to the y-axis. The second one, let's talk about the symmetry with respect to the origin. Okay, so with respect origin. Okay, so yeah, let me give you an example. Okay, so a typical example would be cubic function like x cubed, right? So something like this. Oh, I meant to change the color. I guess I didn't succeed. So let me erase this. Okay, so something like this. Right, so this would be some cubic function. Could be x cubed, could be x to the fifth, etc. Right, so if I have a point, let's say I have a point, this one, x, y. And then if that function is symmetrical with respect to origin, I have a corresponding point right there, also on the graph. Right, negative x, negative y. And then the condition for a function to be symmetrical with respect to origin would be something like this. So I will take f of x, right, and I would get f of negative x, right, with the negative in front of it. I put that negative there, right? I didn't leave space there. Anyway, right, so you guys see that. So if I took f of if I took negative x and plug it into the function, right, I would get y with the negative, right, in front of it. Okay, so yeah, it's over here. And this type of function is called odd. All right. Yeah, so let's look at that last type of symmetry. Even though those relations, right, and graph of that relation would not be a function. So this one is with respect to x-axis. And let's look at a quick example. And so something like this. Okay, so you guys, I hope you see that symmetry. Right, so if I have a point here with coordinates x, y, then I have a corresponding point right there with coordinates x minus y. Okay, and then again, right, we have the condition for a relation to be symmetrical with respect to x-axis, it would be something like this, right? So if I take f of x, I would get f of x, but with a negative. Okay. Yeah, so that's a that would be a relation, right? That is not a function, right? If we have this type of symmetry, and because for the same input I get two different y's, right? Positive y and negative y. So relation like that is not a function. Okay, so let me show you an example of how we would find whether the function is symmetrical with respect to x-axis or y-axis. Okay, so let's look at example 3. Did I say x-axis and y-axis? X-axis, y-axis, and then origin. So example 3. So determine the symmetry. Okay, so the function that we will try to analyze is this one. And so the one we just saw, x cubed minus 4x. Okay, so let's start with maybe whether the function is even. And so we're trying to answer the question, is this function even? And the condition for that was f of x was supposed to be the same as f of wait, erase this. F of negative x. And so those two should be the same. So we simply take, and we have the original, let me rewrite it here. So f of x was x cubed minus 4x. And I'm supposed to check whether if I plug in negative x into the function, right, I'm going to get the same expression, or the same function. Okay, so I go negative x cubed minus 4 times negative x. Okay, so out of that first computation we get negative x cubed. And here we get plus 4x. And so we check it against our original function, and yeah, we can see that they're different. So that the conclusion is that this function is not even. Okay. Yeah, so I'm not going to be checking whether the function is symmetrical with the x-axis, because the function is the relation is a function, right? So I know that it's not going to be symmetrical with respect to x-axis. Anyway, so the second thing we need to check is whether the function is odd. Okay, so I take, again, right, I'll rewrite that original function. So it's going to be x cubed minus 4x. And now I already have that f of negative x, right? So the only thing I need to do, let me write it like this. So maybe let me change the color. Okay. So let's do f of negative x. Right, so that's this one. Negative x cubed minus or plus 4x. Okay, and then what I need to do, I need to take a negative, right, put it in front of it, and check whether, if I distribute this negative, whether I'm going to get the original function. Right, so let's try it. Okay, so I get negative f of negative x. Okay, so I'm distributing this negative. I can draw the arrows. Okay, so the first term will be x cubed, right? After I distribute the negative or multiply by -1, same thing, minus 4x. Okay, so I check it against the original and we can see that they're the same. So we confirmed that, or proved, showed that the function is odd, right? So it's symmetrical with respect to the origin. Okay, so let's write it. The function is odd. Right, so symmetry with respect to origin. Okay, let me stop. Or actually, let me give you a practice problem. Okay, so for practice, try something like this. Let's do f of x maybe negative x. What can we do? How about x squared plus 1? Okay, so check. Yeah, so this is also a function, right? So you don't need to check whether this is symmetrical with respect to x-axis. Just do whether the function is even. And maybe check this first, right? And then check whether the function is odd. Okay. All right, let's take a break.